Alright, so now we're going to talk about one of these cardboard box problems. So when we're drawing the picture for these, it's important to note what the base is. Sometimes it will be a rectangular base, sometimes it could be a triangular base. In this case, it's going to be a square base. So we're going to draw our square base, and we are going to draw a little prism here. And this will be our box. So when we have no top, well, so actually let's start with the 45. So what is this 45 telling us? 45 equals something, right? Equals something important. So with containers and 3D objects and stuff like that, one of the relevant, or two of the most relevant formulas that you're going to have are going to be surface area and volume. Kind of like how on the rectangular field problem we had perimeter and area, surface area and volume are two of the most important formulas for this type of problem. So now what's the surface area of this box that we're talking about? Well, we know we need something that is length times length, because notice we have a square base. So normally the area of a rectangle is length times width, but if it's a square, it just equals like length times length or width times width or whatever you want to call it. So that's going to be our base. And then we are going to have 1, 2, 3, 4 sides where it's going to be length times height, right? The height of the box. And then there's going to be no top, so we would not count this. If we were counting this, it would be another length times length, right? Same as the base. But since it says we are building a box with no top, that is not going to be included in our problem. So 45 equals L squared plus 4LH. Okay, so now let's think about solving this for for H, because we want to solve for H. Because if we tried to solve for L, we would end up with an L in our solution, right? Because we got squared and we got L over here. So we're just going to solve for H. So 4LH equals 45 minus L squared. And then we could divide both sides by 4L, and we get H equals 45 minus L squared divided by 4L. Okay, so this is our H. So now we want to think about our area formula. So the area of a thing with a square base is going to be L squared times H. So now we just substitute in this H for this H, and we get A equals L squared times 45 minus L squared divided by 4L. So now we're going to simplify this. A equals L to the fourth, or negative L to the fourth, plus 45 L squared, all divided by 4L. So then this L can cancel with this, making that a 3, and making this a 1. And then, so then we're left with A equals negative L cubed plus 45L over 4. All right, so then now, just going to rewrite it as 1/4 times negative L cubed plus 45L. So then we're going to go ahead and we're going to take the derivative of this, and we're going to get 1/4 times negative 3L squared plus 45. And then one thing that we can do to this that will make it a lot easier to work with is we can factor a 3 out, right? We can pull a 3 out front. So we're going to get 3/4 times negative L squared plus 15. So this is going to make it easier to make our sign chart, right? So this whole thing equals 0 when this equals 0. So we just need to set negative L squared plus 15 equals 0. So that's when 15 equals L squared. So L is going to be plus or minus the square root of 15. So we're going to go ahead and make our sign chart. We got negative square root 15, and we got square root 15. So now we need to think about it. So if we are going to be if we're going to plug in this, or if we're going to plug in something on this interval, we are going to get a negative number because it's going to get squared, making this positive, but then this makes it negative, so it's going to be a huge negative number plus 15, which is going to be a negative number. Then it's going to be positive on this interval and negative on this interval. So then we can say we have a local max here and a local min here. And since this is the only local max, right, we only have one local max. So then we can use the first derivative test to say, okay, this local max is also the absolute max. Because we are decreasing on this interval, we are decreasing on this interval, only increasing here. So the only potential location for an absolute max is going to be right here at this local max. Okay, so then that is our L. Our L equals the square root of 15. That is our final answer for L. So now the only thing left to do is just to solve for that W. And we're going to, or not W, H. So we're going to go ahead and we're going to grab our original function and paste it here. And so now we're just going to plug in square root 15 for L. 45 equals square root 15 squared plus 4 square root 15 times H. So 45 equals 15 plus 4 square root 15 times H. So we can move that 15 over, make that 30. 30 divided by 4 square root 15 equals H. We could make that 15 over 2 square root 15, why not, equals H. So that's going to be our final answer for H and our final answer for L. So those are going to be the dimensions of our cardboard box.